So let's go back to the next element. So the next one is very simple. For the next element, let's go with a input source containing both a DC term and a time varying term. And this one is pretty simple. The large signal model for this is simply the large signal part of the source, VI, and the small signal part of the source is simply the small signal part of the source. Okay, so the small signal part of the source is simply related to the small signal input VI of t, while the large signal is related to the DC value. Okay, so that is pretty straightforward. Next, let's do a resistance. We should be able to linearize a linear element. Yeah, resistors are linear element because linear elements because they satisfy both the homogeneous property and the superposition property. You saw this from sequence three, the first sequence of the second week of the course. And so for these linear resistors, they satisfy both the homogeneous property and the superposition property. And but we can still linearize them. Never hurts to linearize a linear element. And so for a resistor, notice that I can build a large signal model for the resistor, which is simply the resistor itself. And VR equals RIR is the equation that relates the current and the voltage. And I can do the same thing for the small signal model. Okay. And for the resistor, how does a small change in VR relate to a small change in IR? So if I change VR by a small amount, how will IR change? Well, it's a resistor and it's linear, so it is going to behave like a resistor itself of the same value. Okay, so I get an IR here and I get a VR here, and VR will be equal to RIR. Okay, so that is the straightforward relationship between the voltage and the current, the small signal V and I for a resistor. I can also do it analytically as we discussed earlier. So VR would be given by del of R IR del IR for IR evaluated at capital IR and times small IR. Okay. So in this case, del by del IR of RIR is simply R. Okay, so there you have it. So not surprisingly, these two are the same. So for a resistor, its linearized model is the resistor itself. Okay, finally, let's go do the model for a nonlinear device D. We've done this before, but I'll do it again. This is our export dweeb hypothetical device with IV relation given by ID equals A e raised to B VD. So it's a large signal model. Was not surprisingly the nonlinear device model for the device with the operating point values replacing the VI